Yeah, it's going. Yeah.
You want me to restart?
If you want to.
Do y'all want me to?
Yeah, okay, just for the recording.
Like, is it self-explanatory? Okay, whatever.
Johan, I would also zoom in on your screen a little bit. There you go, buddy.
Is that better, everybody? So sorry. Okay.
It's already bad enough, so.
Okay. So m squared minus, or we're trying to prove that m squared minus 4n minus 7 does not equal 0. So first we have the assumption that m squared minus 4n minus 7 is equal to 0. Therefore, m squared is equal to 4m plus 7. And then we broke the 7 down into 6 plus 1. And the reason we did that is so we can get m squared is equal to 2 times 2n plus 3 plus 1, which makes it an odd number because of the plus 1. And so because of that, now you know that m as an integer is odd. So therefore, we know that an odd number is equal to 2k plus 1. And so m is equal to 2k plus 1, where k is an element of the real. And then because of that, I plugged m back into what we just found for m, 2k plus 1, into this original equation right here. And so 2k plus 1 squared is equal to 4n plus 7. After foiling, you get 4k squared plus 4k plus 1 is equal to 4n plus 7. And then I move that all over. And so after combining like terms, you get 4k squared plus 4k minus 4n. Minus 4n minus 6. And then I factored out a 2 because you can do GCF in that. And then after that, you can move the 3 over. So this becomes 2k squared plus 2k minus 2n minus 3. And then I move the 3 over and factored out another 2. And so this is where like the math of it stops, and we've proved a contradiction. We've established that k and n are integers. The n was the given one, the k we did up there. We also know that 2 times any integer is even, and therefore 2 times a number here can't equal this because 3 is not an even number. So therefore it's a contradiction, which then proves our original statement. Yeah? Okay, great. Cool comes. Did everybody get that? Okay.
Isabella, can you share the screen?
Yeah. Okay, Sonia, can you read the problem, like the original problem, because I don't have it pulled up right now.
Yeah. Prove that there is no x element of all real numbers such that 1 over x minus 2 equals 1 minus x. So first we assume that there exists a real number, and then we represented that by c. So that's why we put c instead of x. So we assume that a real solution x equals c exists. And then we start solving for c. So we FOIL, we times the c minus 2 to break
Right, this part is just like algebra. Like you multiply the c times 2 over here, and then you, or the c minus 2, sorry. Whoa, what just happened? Okay. The c minus 2, so then you do 1 minus c times c minus 2. So like Sonia said, that's just like the basic foiling. And then you get the quadratic, you should end up with the quadratic c squared minus 3c plus c equals 0. Sonia?
Rock, do you want to talk about the discriminant?
Sorry, so as we know, we can decide if a quadratic equation has a solution or not by calculating for the discriminant, and the discriminant is determined by
b squared minus 4ac.
by annotating doesn't work anymore. So can you write down the formula for the discriminant? B squared minus 4ac.
Just put it in the chat instead.
Sorry, Knock. I'm having a hard time hearing you, but yeah, so essentially, that's not what I meant to do.
Can you guys hear me? Maybe my mute wasn't working.
No, you're not on mute. It's just like very faint.
Is it better now?
A little, yeah.
Okay. Yeah, so the discriminant is that. So in this quadratic equation, our b is minus 3, A is 1 and C is 3. So we got the discriminant to be -3. And since -3 is less than 0, the quadratic equation does not have any solutions to it. Therefore, there is no value of x that could satisfy the given equation of 1 over x minus 2 equals 1 minus x.
Right, and that would make it irrational. Or imaginary, sorry. Did everybody get that? Because I know it was kind of hard to hear knock at the end there.
Could you repeat it because I couldn't quite hear it?
What do you just need that discriminant part?
Yeah, I understand like how you got there. Yeah.
Right. So essentially what happens is after you FOIL it, you get that quadratic, right? And then basically the original, I can't remember the wording of the original problem, but Sonia, what does it ask us to prove again?
Prove that there is no x element of all real numbers such that 1 over x minus 2 equals 1.
Right.
1.
So essentially you're trying to prove that like the discriminant would be less than 0, because as we've learned, if the discriminant is less than 0, then that means that its x wouldn't be all real integers. It would be an imaginary integer. So what you do is you just use the discriminant formula of b squared minus 4ac, and then we found a to be 1, b to be -3, and then c to be 3. So we just plugged it in here. And then we got 9 minus 12, which is -3. And since -3 is less than 0, it proves that it proves that there's no value of x equaling all real integers to satisfy the equation.
Okay, cool. Thank you.
Tomas, are we next?
I don't really remember the order, but we can go next.
Yes, you're next.
Okay, I'll screen. Or do you have it, Leonard, or do you want me to screen share?
Just screen share.
Okay. All right. So we are proving that if n squared is even, then n is also even. So we have to let n be
Odd for this to happen, and from the notes we know that n is equal to 2k plus 1, where k is the element of z, k element of z. Remember that that's essentially just like integers. Yeah.
So then n squared is equal to 2k plus 1 squared. Thus n squared is equal to 4k squared plus 4k plus 1. And you can take out a common factor of 2 to get 2 times the quantity 2k squared plus 2k plus 1. And then you now you let m equal to 2k squared plus 2k. And then you let then n squared is equal to 2m plus 1. And then you want to finish it off?
So yeah, so by definition, n squared is odd, right? But this is impossible since we literally just proved this to be wrong, and therefore n squared has to be even.
That's because the definition of an odd number is 2k plus 1.
Yeah.
And by substituting the m in for the quantity 2k squared plus 2k, we get the definition of an odd number.
Yep. Everybody get that?
Yeah. Liz, you and I are next. Okay, I got it.
Are you sharing the problem or?
Okay, so we have this one right here. If n equals z, then n squared plus 1 is a prime number. So a counter example to that would be if n equals 9 plus 1, then it is not a prime number. And so that the counter argument and proves that it is false. And then Liz, you want to do the second one, or you want me to do it?
Yeah, I can do the second one. So this one is.
Well, wait. Did everyone get the first one? It's pretty self-explanatory. Yeah. Okay. Cool.
Okay. So for the second one, finding a integer that's a multiple of 10 and 12, and that it is or it isn't.
We're trying to prove that it's false. So like.
Oh, okay.
You know that-
I understand. Okay, so a way to do this is obviously we know that 10 and 12 are both no. Yes. Anyways, so an easy way to do this is writing out all the multiples.
Liz.
I know 12.
Okay, but there's like.
Liz, just say the answer.
Oh, it's 60. Okay, it's 60. Do you understand why?
Okay, I got it.
No.
So, like, 60 is not a multiple of 120 because 120, like the multiples just keep on going up. So like we know it's 10 and 12, like their multiple is 60, but like, and 10 and 12 is a multiple of 120, but 60 is not a multiple of 120. So therefore this statement is false.
Does that make sense? Wait, can I share my screen really quickly?
Yeah, go ahead.
Okay, wait, hang on.
The multiples like 120.
Hang on. Okay. Wait, can you stop sharing real quick?
Yeah.
This is the illustrated. Do you see?
I'm so done with you.
Liz, that's not.
No, like I'm explaining how you explained it to me.
That is the least common multiple between those.
Just ignore the top.
She's saying that it is the least common multiple, which is correct. The important key factor, there's another example. Can anybody tell me another least, not the least, but another common multiple that would not be a multiple of 120?
Liz, what?
Anybody besides Liz and Jacqueline? What would be the next number that would be a multiple of 10 and 12, of both 10 and 12, but would not be a multiple of 120? Yeah, I think Jacqueline knows, but I'm
180.
Yeah, 180. So 180 is divisible by both 10 and 12, but is not divisible by 120. 60 is a multiple of both 10 and 12, but is not divisible by 120. Okay.
Did I do something wrong?
No.
Oh.
You were just like, going all over the place with that. I was like, what?
Anyways, I tried.
All right. Does anybody have any questions about those problems? Okay, so on both of those, there were other IB problems. Over Thanksgiving break, I would encourage you to look at those. I'm not saying you have to do every single one. I'm not saying you have to write them all out in words, but I would highly encourage you to look at them, maybe talk to each other about them to see if you can figure them out, because there is no Delta Math for this HL stuff. So that is the equivalent of your extra practice, because seeing 8 problems is not enough practice. Okay. As far as over Thanksgiving break, the same goes for SL. You just need to work on your test corrections and your IAs. The more you get done on your IAs over this break, the less you have to do over Christmas break. Okay? Any questions about HL stuff? I'm pretty sure your test is going to be the second week that you're back from Christmas break. So not that first Thursday, but the second Thursday. And I'm going to double check really quickly that I think you have me again for 2 days a week at some point. Yeah. So you come back on November 30th, Monday, November 30th. And then Wednesday, you have me for HL, and Thursday, you have me for HL. That's the December 2nd and December 3rd. You have me for HL. As far your unit test your HL unit test should be on December 10th. What I offered to you all as a potential difference would be giving yourselves an extra amount of review by having review Thursday during class, as long as all of you are available to take your test Thursday after school. Y'all can discuss amongst yourselves over the next couple days, and over Thanksgiving break, we can come back to that eventually. But otherwise, you don't really have designated review time.
Is the HL unit test our final, or is that separate?
What was that, Rohan? Sorry.
HL unit test will be counted in our grade, right? It's not like the finals thing.
Right.
And so there's a separate HL paper.
Will be counted, yes.
Okay.
Wait, Miss Thompson.
So,
are you saying the review? Wait, can you repeat that part again about the review? I was confused.
all right, here's today. We just did proofs by contradiction. You have another lesson of proof. We just did proof by counterexample. I think we have one more proof section that we have to do. I'll double check. But that means that I think there was one more lesson here on this Thursday that I moved. I like combined these two so that I could put that one here. So this day will be a review that Thursday. The following Thursday, you have your test. What I am willing to offer, since you won't have seen the material in a while, sort of, is to have a review session during Irish time. And then if everybody is available to take the test after school, we can review during Irish time, and then you take it after school, so that you get a chance to review right before you take the test. But that is only if that works for everyone. But y'all can talk about that amongst yourselves. But otherwise, y'all are good for today. Does anybody have any questions?
No, I have something on my IA, but not like this.
Okay. If y'all don't have any questions, y'all are free to go.
Thank you.
Happy Turkey Day.
Okay. Miss Thompson, I found some. It's still recording. If you want to